All right, I'm going to go ahead and get us started. So greetings and welcome everyone to this webinar, where you will be among the first to see an incredible new technology for monitoring the extent of the world's cropland. Today is also Wangari Maathai Day, and I hope you will join all of us in celebrating the incredible contribution she has made to some of the very issues we'll be discussing today. My name is Crystal Davis. Some of you may know me as the director of Global Forest Watch, and more recently, also as the director of the new Land and Carbon Lab at the World Resources Institute. Thanks to generous funding by the Bezos Earth Fund, WRI launched Land and Carbon Lab at the end of last year with many partners, including Google and the University of Maryland. And we have given ourselves the ambitious goal of transforming how we monitor the world's land and its nature-based carbon, not unlike how Global Forest Watch radically transformed the realm of forest monitoring not long ago. And the reason we are doing this is because how we use and manage the world's land will have enormous implications for whether we can meet any of our global goals, whether it's to address climate change, stop the loss of biodiversity, create food security, or protect and respect the livelihoods and cultures of millions of indigenous peoples and local communities. Land is truly our lifeline. Yet, there's a finite amount of land on Earth, and the way we're currently using it, there's not going to be enough. So today, we're going to be talking about cropland in particular, because the use of land for agriculture, in particular, plays a critical role in this global land squeeze. On one hand, we know that the world needs to produce more food to bring billions of people out of food insecurity and support a growing global population. On the other hand, if we want to meet our climate and biodiversity goals, we need to stop converting forests, grasslands, and other vital ecosystems into new agricultural land. So the new data we are sharing today gives us an unprecedented high-resolution view of how cropland expansion is transforming our planet in different ways and at different paces across the globe. And with this new data comes new knowledge and insights that can help us shape a different trajectory forward. So we have three exciting speakers in store for you today who will introduce this groundbreaking new spatial data on global cropland extent and change in the 21st century, and also share some perspectives on what these data tell us about the state of agricultural systems globally and on the continent of Africa. So my goal today is to try to save at least 20 minutes at the end to take all of your questions. So feel free to start dropping your questions into the chat box as we go along. We have some folks who are monitoring them there. Without further ado, I'd like to give the floor to Professor Matt Hansen at the University of Maryland, who co-directs the Global Land Analysis and Discovery Lab. So please, Matt, I give the floor to you.
Thank you. I'm very excited to share this work. We have a number of themes that we're going to do time series for, and then the integrated use of those themes will tell us something about rates and the extents of global land surface change, largely driven by human action. And today, talking about cropland dynamics at the global scale, first study of its kind, led by Peter Potapov in our GLAD lab. We rely on time series satellite imagery that are publicly provided by agencies like NASA, USGS in the US, and this is what this study is based on, but also by ESA. And these data provide generic, consistent response from the space perspective with which we can apply algorithms and map at scale the planet. So it's important to emphasize the inputs and the work of the space agencies in providing these data for public good, public analysis, and anyone on the planet can avail themselves of these resources and study their corner of the planet or the planet as a whole. I just go from this false color cloud-free composite as an example of the data that we use. And I'm just going to put a grayscale image here, and on top of which I can put a graphic of our cropland extent 2019 study, which is published in Nature Food by Peter as the lead author. And the take-home message is that the footprint of cropland as a land use is growing, and it is increasing in its extent over time. So we have a nearly 10% increase in just under 20-year period. Half of that 100 plus million hectares replaced natural vegetation. So when Crystal mentions impacts on ecosystem services on intact landscapes that are providing, let's say, carbon sequestration services or biodiversity. It's a big deal if half of this increase of 10% total cropland is in natural landscapes. The big changes are in the lower latitudes. Those are the frontiers of land use change and have been for the past 50, 60 years. We have the biggest area extent change in Africa, largely driven by population demographics, the proximate driver being local populations, self-sufficient farmers and farmers feeding the local towns and cities. So we have a 34% of the gain in Africa. Proportionally, the continent with the largest gain is South America, and South America being the big producer of feed for livestock, feeding livestock and increased meat and diets. And so this big commodity pulse is coming from South America in the form of soybean, sugarcane, and the like. There's a lot of dynamics elsewhere, but in the aggregate, if you think about the higher latitudes, it's kind of a wash. There are hotspots of loss and gain, but the big net gain is at the lower latitudes. And importantly, global cropland expansion accelerated over the study period. So we're seeing a dynamic that reflects both demographic gain and increased standards of living, and the according changes in diets and need for food. And then we can just kind of zoom in. It's just a little show and tell. We have again, there are places of cropland loss, and I'll highlight that. But this little animation here is meant to show just the kind of a sample of the different actions going on. So we have before and after high-res zooms. I hope you can see these. But we can talk about in temperate North America, again, in the higher latitudes, the net is not dramatically different, but you do have land uses like mining, removing cropland from the corn belts. This is an example in Indiana. We have deforestation in the south of the US, and bottomlands converting forests to croplands. If we go to South America, the big hotspot of deforestation, we see tropical gain in cropland due to natural land conversion. In this case, it's the Chapada in Northeast Brazil. It's a dry land ecosystem, very shrubby cover. It's not deforestation, but it's a huge hotspot in row crop expansion. The states of Mato Piba, Maranhão, Tocantins, Piauí, and Bahia. And then this next example is tropical cropland gain due to deforestation in the Chaco, which is another, the Chaco being one of the, I think maybe the largest proportional conversion rate of any ecosystem in the last 20 years. Going over to Africa, we have tropical gain due to largely clearing of woodlands and forests. So the two examples that are zoomed in here are Ghana and then Zambia and Miombo woodlands. Back up to the north, one of the hotspots of cropland loss is due to abandonment in the former Soviet Union, where a lot of older cropland land uses were abandoned due to just lack of productivity, poor soils, but could be back in the mix under climate change scenarios. Russia in particular is a big growth prospect for future cropland expansion, but the shorter signal in recent decades has a big abandonment signal. Then we have in South Asia, tropical gain. There's a lot of intensification in southern South Asia. The subcontinent, you've got double cropping, rain, dry season cropping that just on existing lands is being increased. And we see that as well in our signal. Part of the study looked at primary productivity, and we see per area increases in productivity for existing croplands, but also at the edges, extensification of cropland. And this is an example of natural land conversion in Rajasthan, dry land, India. And then in China, big losses due to urbanization in what are the bread baskets of China, such as the North China Plain. If you think about Shanghai and Beijing expansion and all the urban hierarchy, they're growing uniformly as populations are reorganized to support the manufacturing sector. And the last one, tropical gain due to deforestation. A place like Southeast Asia and insular Southeast Asia, big changes in forest cover due to cropland expansion. So just some show and tell. The data are available. They are simply the cropland area extent, but behind that is a lot of information on a lot of ways forward to discover, what proportion of this change led to outcomes, different outcomes, and what was the reference land cover in terms of carbon stocks and like. So we think this would be a nice, obviously a great layer to integrate with other information data sets to tell interesting stories on impacts on ecosystem services and the like. So we're working to combine this with other layers, and so this is part of this idea of integrating themes. So I'm just going to take a little tour of a couple places here. This is part of the Bezos watch, and it's a very complicated land cover scheme. I don't want you to absorb all that, but to just show you the impact of cropland and its interplay with across regions. If we zoom into the arc of deforestation and out into the Cerrado, you see this orange color growing. That is the cropland layer, and that's its big growth. You can see in the Cerrado on the right side of the screen, not in the rainforest. With the success of the soy moratorium in the Amazon basin, where soybean is not directly replacing deforestation, you could argue there's a leakage to the Cerrado where there's less regulation, let's say not even regulation, but less collaboration between industry and civil society and the like to limit cropland expansion in that ecosystem. And then this shows the red color is the clearings related to cattle pasture. So the land use dynamic in cropland gain in a lot of Brazil is to replace pasture, and pasture is displaced into the interior of the Amazon. So pasture land use is the deforesting land use, but soybean is backfilling on the older pastures. And we'll just zoom in here and we'll see this olive tone is pasture land in 2000, and then this orange tone is cropland. So most of that orange just replaced an existing land use, but it doesn't mean it's unrelated to deforestation. And a lot of these commodities, such as soybean, go to feed chickens, pigs, and the like. And China, through its economic development, has rapidly urbanized. And we look at this North China plain, the orange, and you can see that this cyan color is urbanization. So we'll zoom into the northern end of the North China plain, and this is Beijing at the top of the image, and Tianjin in southeast, and you can see this is the loss of cropland due to the higher order value economic activity of manufacturing and industry in China, and the fact that populations with increased wealth, increased employment opportunities, and higher value employment opportunities have improved diets. And so the big pull of commodities to advance that food production in China is reflected in this. And this manufacturing of higher order, the phones and the different consumables is really consumed in the West largely. So we're all part of this commodity chain and the resulting kind of chain of events on the land. Zooming into Africa, we see the expansion of cropland. It's not as intensive. It's not part of largely as part of the global commodity chain. But just this zoom of East Africa, you can see the expansion of cropland from Uganda to Kenya to Tanzania down to Malawi. We'll zoom into an area of Western Tanzania and just toggle back and forth in this huge, advance of cropland. And again, it's not intensive, it's not high yielding, and it is largely, we can suppose, related to growing populations. That by 2100, the UN projects 5 out of the top 10 populated countries in the world will be sub-Saharan Africa, with Nigeria number 3, DRC, DR Congo number 5, and countries like Uganda and Tanzania in the top 10. So this sustainability question is really huge in Africa in terms of intensification, alternative livelihoods and the like. So development prospects around and the impacts of on cropland and natural systems is a huge one here, not a clear answer. And we can go back to the developed West. I'm from the Midwest in the United States, in Indiana, which is at the center of this picture. And the net here, you see growth and at the edge with the dry tolerant varieties, cold tolerant varieties of corn and soybean expanding in the upper Midwest. small deforestation events opportunistically in some bottomlands, but also loss of croplands due to urban expansion. So the only dynamic we'll see in this zoom centered on Indiana is a little bit of urbanization and the loss of cropland. And so I think the big thing is when you think about cropland land use and deforestation. I mean, I'm from Indiana in the late 19th centuries. 90% of this was hardwood forest. There are no deforestation-free commodities coming out of Indiana. Just want to make that point. But this is fairly locked in land use and not the site of dynamic change. The net is not quite zero, but the real action in terms of conversion is at the lower latitudes where there are natural lands to be converted. That's all I have right now. That's the summary of some of the broader high level findings in terms of extents and rates and some of the storytelling behind it. And the implications I think are really great. I think Tim's going to get into that. But we hope the data are used to discover underlying dynamics and information on impacts. Thanks, Crystal.
Great. Thank you so much, Matt. That was fantastic. And as Matt said, this new resource is publicly available to you and waiting to be mined for insights. So I encourage you all to go online at landcarbonlab.org and you can start exploring with the data. And I also encourage you to reach out to us and tell us what you discover. But I now want to turn to Tim Searchinger, who is a senior fellow and technical director for the food program at WRI, and also a senior research scholar at the Princeton School of Public and International Affairs. And I've asked Tim to share his perspectives on what these data tell us about global cropland trends, which we perhaps did not know before. So Tim, what's new here and why does it matter?
So this is a very important study. And there has been, in creating a sustainable food future, this big report we did in 2019, we have a section where we talk about the conflicting data about what's happening with global agricultural expansion and the different types of satellite products, FAO data. And the part of the big challenge has been that studies haven't been able to identify the net effect of cropland expansion. We've mainly had from satellites, cropland gross expansion into forests and just forests. So now for the first time, because Matt and his team, Peter, did this incredible amount of work, we have this image understanding of what's going on with net expansion. And it is much worse than what we had believed. So this paper analyzes is the expansion of annual arable cropping. And that is about 5 times the estimate provided by FAO data. Now, the FAO has a really tough job. They basically get their data on this from countries. But basically what we're seeing is about, in the last 8 years, about 10 million hectares of expansion per year. And that's about 5 times the FAO estimate. Now, the FAO has a separate category called harvested area, which is done in a different method, which is analyzing how many crops are harvested per year. And that's been going up at a record rate. But because their country reporting suggested that cropland area was not going up, the suggestion was this was all being accommodated by double cropping and things like that. But in fact, we now know from this paper that that's not the case, that the problem is in the country reporting of cropland data. So we're having an expansion that is at a very high rate. Now, it's actually even worse than that because the study is not able, because of the challenges of looking at different types of images, to look at just the conversion to permanent cropland, like oil palm is what you're looking at here, rubber and coffee. There was a little part of the study that found that about 1 million hectares of arable land is being converted to these permanent crops, and that's additional to that 10 million hectares. And the FAO data suggests that this is expanding about 2 million hectares per year. So it's even worse, in other words, than the number we would otherwise have. Another critical factor is that this is just the numbers we've been talking about are the net numbers. So this paper is able to distinguish gross cropland expansion from net cropland expansion. And the gross expansion is almost twice as much as the net expansion. Now that's a big deal because obviously when you have land, some land and only some of the cropland that is being abandoned is being regenerating, at least in this time frame, as natural vegetation. But even when that happens, that takes a long time. It has nowhere near the biodiversity. A great deal of the regeneration into forests is in these highly managed plantations. But we are clearing natural habitats, losing the biodiversity and carbon of that. So the number could be almost twice as much in terms of the actual losses compared to the net gain. So one of the reasons this is so important is that there is an impression, again, if you look at FAO data, that even with cropland expansion, even though they underestimate it, there has been a large decline in total agricultural area because the FAO data has country reports claiming that pasture area is declining. Now, pasture area is about, under FAO data, about 3 billion hectares globally, so twice the size of cropland. And there have been country reports claiming there's a decline in pasture area. Now, this is a bit strange because if we look at this slide, this is just the kind of gross loss of forest to pasture. Again, basically from Matt's data as interpreted with Global Forest Watch. And we know that most of the conversion directly to agriculture from forests has been for pasture. So what is it going on that claims that actually pasture area is declining? So this is yet to be, we don't have the same type of study as this one on pasture area, but we can basically, we're beginning to get a picture that this is just not true at all. That at least in terms of the conversion of natural areas to pasture, it's going on at a good rate. So here's just a quick example. In Australia, one reason a big claim is that there's a decline in pasture area is that in Australia, they've been reporting declines in pasture area on a huge scale for now several decades. And if you look at just the picture of kind of Australia, what you see is most of Australia is really, really dry. And, so it's outback, it's got very, very, very sparse vegetation. But in the past, Australia has declared that almost 2/3 of its land is in pasture. And what's happened is over time, they've taken a lot of this very dry land and decided it can no longer even be designated as pastures. It's too dry or no one's been putting a few sheep on it. So Australia reports this huge decline in pasture area. But in fact, one of the things that's going on is that there is massive clearing of forest and other woody vegetation in the wetter parts, this parts in the east, which are wet for pasture. And there was a very detailed study just released of Queensland, and in just 1 year, almost more than 500,000 hectares of land were cleared for pasture in Queensland. So the FAO data is giving this impression of a decline, but in fact, what we know is that there's a lot of expansion of pasture. Brazil is another example. FAO data claims that Brazilian pasture area declined from, this is from 1985, I think, on by 6 million hectares. There's a new study using good satellite data suggesting it's actually expanded by 55 million hectares. And actually the gross expansion is 83. So this is the pasture to crops is what Matt was talking about of pasture being converted to soybeans and other things. And you get a knock-on effect. But then on top of that, there's a 55 million hectare increase. Why is that? Why could they report a decline with this kind of satellite? And I think the answer is probably that a lot of Brazil was naturally the Cerrado, which you see here in the background here. And the Cerrado would have occasional cows on it. And so probably vast areas of natural vegetation were declared to be pasture in the past. And then as it's actually cleared and the whole natural vegetation is replaced with this typically Brachiaria grass, that's not reported as a change. But in fact, we have large scale expansion. Okay. So what are some of the implications of that? So first, we are underestimating the amount of greenhouse gas emissions from land use change. And there was the Global Carbon Project, which is typically looked at for the kind of estimates of the global emissions, reported at COP that there was a decline and emissions, that's based basically on these bookkeeping models that basically rely on FAO data. And so now we're going to have to go back and really reevaluate the massive amount of expansion occurring. Another implication is that there are all kinds of people talking about making additional uses of land to solve climate change, which more or less assume that the land is available, but it's not. And a good example is plans for yet more bioenergy. The European Commission Climate Strategy for 2050 relies on basically converting an area of cropland, roughly 1/5 of European cropland, into energy crops. Well, if we're still expanding massively land just for food, we don't have additional land for bioenergy. But this is also true. A lot of people want to rely on natural climate solutions, reforesting vast areas of land. We can't reforest vast areas of land without just having other conversion elsewhere until we actually manage to shrink agricultural land area. So we think the solutions at WRI, we call them produce, protect, reduce, and restore. And I just want to highlight kind of the emphasis on produce. Produce means producing more food on the same land. Protecting means linking that explicitly to forest protection. Reduce is reducing demand for land-intensive products, whether that's particularly beef, but trying to hold down the diet shift, trying to hold down meat and milk consumption, but also bioenergy. And then when we have land available, we can then restore at large scale. We can restore some areas now that are kind of too marginal for agriculture, but basically large scale restoration is going to depend on reducing this, exactly what we're seeing here. And I just want to give a little bit of a point on that. We did an analysis of the greenhouse gas emissions and the amount of land it would take to feed the world in 2050 with today's farms. So these are the greenhouse gas emissions in 2010, which was 12 billion tons. And about 5 of that were emissions from land use change. And in 2050, though, that would rise to 38 billion tons. Now, remember, we basically need to have greenhouse gas emissions close to 0 in 2050. That would involve conversion of 3 billion hectares of land, like 4 times the continental US. And so we need this green bar is the yield gains that would occur just if we manage to maintain the historic rate of yield growth and some livestock efficiency gains. And that just gets us down to the 15 billion tons. We still clear hundreds of millions of hectares. So the point is that yield gains, increasing productivity per hectare remains absolutely critical, as well as reducing demand. The last thing I'll just say is that the epicenter of this, we're having change everywhere, but the epicenter now is sub-Saharan Africa. And we've known that is coming for a while. And that's because of the large-scale population growth and the fact that yield growth has been slow. For a while, it was picking up. It's back down again. The world has a purely self-interested need to help people in Africa to increase their food production, and linking that to actual forest protection and combining that can be the kind of common interest and thing needs to be pursued. And obviously there's an important need, which is to feed people in sub-Saharan Africa. But even if you only cared about solving climate change for people in North America or Europe, we need to help Africa to increase its yields. So I will stop there and turn it back to you, Crystal.
Thank you so much, Tim. Very fascinating. And I think you show how complicated these dynamics are when we start digging into the data locally, and also the fact that no one data set gives us all the answers. And I think Matt's presentation showed that as well. Like, the insights really come when we start combining different sources of data to answer some of our tough research questions. So to finish off our panel, and before we have a chance for questions, I'd like to turn it over to Wanjira Mathai, who is the Vice President and Regional Director for Africa at WRI. And the true power in these spatial data is our ability to simultaneously see these trends on a global scale while also zooming into specific places. And when we do that, we see that global trends can actually mask the fact that the story in one place can be quite different than another. And that means that the solutions are also potentially quite different. So Wanjira, please tell us what these data show us in Africa and what this means for how we think about the sustainability of agricultural systems on the continent.
Thanks, Crystal, and thank you for sharing this. This is such landmark work, especially because it comes on the heels of not very good news on climate impacts and vulnerability that we saw on Monday. And you know, the reality of this report for Africa is particularly stark on two grounds. One, the fact that most cropland expansion occurred in Africa and South America, the fact that Africa, in fact, experienced the largest area in net cropland expansion. That's huge. It's huge, and I'll mention a couple of reasons why, in particular, around the role of agriculture in the economy, the African economy, and also in the jobs creation agenda. And so this is extremely significant that we would see so much movement in such a short time. And then, of course, that half of the cropland was actually replaced by natural. It replaced natural ecosystems. In fact, therefore, cropland is competing with the ecosystems like forests that are in fact cushioning us against the impacts of climate, and of course delivering critical ecosystem services, in particular regulating rainfall patterns, because agriculture on this part of the world is largely rain fed. So you have too much water or too little water, and that is really significant. So it's critically important, therefore, as I mentioned, because agriculture remains the most important economic sector for the continent. Across the continent, it is agreed that agriculture is the predominant sector in the economies of most of the countries, accounting for close to 40% of GDP. And in the sector in particular, it is also the leading source of jobs for the African population. So you can imagine the impact of that sector on this growing cropland. And then, of course, agriculture is therefore at the crux of climate vulnerability, and therefore the impacts on agriculture have a significant impact on both the economy and livelihoods. I also want to add the fact that because agriculture is so predominant in our economies, and most of that agriculture is driven by small-scale farmers, a majority of those small-scale farmers, we know, probably on average 43% of the agricultural labor force are women. And so again, you can draw the correlations, what the impact is on communities, on women. That is extremely stark. So you have poor rural women disproportionately vulnerable to the effects of climate change, and then of course facing this additional challenge of agriculture that is dysfunctional. So that's a really important piece to understand. Of course, we've got to close the gender gap in agriculture to improve and adapt against climate change, but we cannot do that in a sector that is already crippled by the impacts. And of course, now we see the pressure on the very ecosystems that regulate the vulnerability of communities. So that's really important. The other piece that I just want to highlight that is perhaps the most important elephant in the room is the fact that poverty in this part of the world is really the most important agenda driving change that we're trying to change. So we're trying to get a situation where poverty, being such a dominant determinant of vulnerability on the continent, is attached to a sector that is so vulnerable itself, and that it is facing such an attack. So those pieces are really important, because as we consider issues like the just transition on energy, the opportunity to power agriculture, we have to remember, therefore, the paradigm that Tim mentioned, that we have to produce in a much more efficient way. We've got to produce food and look for agricultural techniques that are not expanding cropland. We cannot expand. We have to produce on less or the same amount of land that we have for a really fast growing population, have the fastest in the planet on the continent. Then of course, reducing waste and reducing the amount of food waste in particular that would allow us not to necessitate more food being produced. Protecting and restoring landscapes remains a very important agenda on the continent, and movements like AFR 100 will continue to be crucial in the light of data like this. So I'll stop there, Crystal. Thank you.
Thank you so much, Wanjira, and thank you to all of the panelists for helping me keep the promise to save 20 minutes at the end for questions and answers. And thank you, Wanjira, for really driving home the point that this is not just about climate change. It's not just about biodiversity. It's about jobs and livelihoods and economic development and resilience. So we have quite a few questions coming in. I'm going to do my best to try to filter them and direct them to the right panelists. If your question doesn't get answered today, feel free to follow up with us, and we'd love to continue the conversation offline. But let me start by directing a few of the more technical questions towards Matt Hansen about the data. I see here one question about, sorry, give me a moment here, about the data in Africa in particular, and one person asking why we see such a large range in the cropland expansion estimate compared to other continents, and whether this has something to do with smallholder field size / a more heterogeneous environment. And then there's a few other questions, Matt, about the prospects for digging a bit deeper into this data, and if there's a way to start to determine what percentage of this cropland area is related to food production versus other agricultural uses, and also how the cropland area data perhaps relates to information we have about yields and intensification. So if I could pass that over to you, Matt, love to hear your thoughts.
Thanks. Yeah, the less intensive the signal is in terms of reaching a closed canopy, a high productivity, high yields, the harder it is to map. And a lot of African ag is a lot of the agriculture in places natural vegetation looks less vegetated. There's a lot of bare ground in the background. So when you see that higher uncertainty, that does reflect the difficulty of mapping small scale, low intensity croplands. We can drive that down for sure. This is just the first try. We will both make better maps, which will be improve the spatial, the fidelity of the spatial explicitness of the map, but then we'll also produce more precise area estimates through our sample-based work. So the areas that we report are samples of reference data that allow us to provide uncertainties. So they're not the map pixel count. So we're doing both those things to work on the mapping and the area estimation. The second question, I mean, there's a lot of stuff. There was on the second question, but I think a couple challenges. One is, when we do our field work and our mapping, we're not differentiating we have crops that could be used for silage. We have crops that be used for silage on a ranch and never make it to the market. We have crops that are going straight into the global market to trade across the planet and feed animals in distant places. And we have in Africa a lot of products that don't make the market. So this idea of what crops are ending up in what particular use case we don't see from space. So this is an open question. On the yield side, that has always been a challenge with the satellite because it's analogous to forest carbon. You have a large biomass plant, corn or soybean, and if it missed its flowering period, you just might have a lot of biomass and no yield. So yield is something that we are working on. A lot of people are working on yield, but getting it on a operational scale, reliable is still to be done. So that's like a research to operations question. The other thing we are doing is as part of the Carbon Watch is breaking up the cropland mask into key commodity crops. So taking a first order cut at the big production landscapes for things like soybean and wheat. And we do 90%. We cover now operationally 90% of the soybean production area in the globe, and it's the American hemisphere. We do North America and South America every year. So we'll be able to, and we're adding sugar cane. And so we'll be able to kind of bring some context to the cropland pixels as we move forward. And the things are really crop type, yield, and a couple other things that we'll hopefully be able to investigate if not get to operational state.
Great, thank you so much, Matt. And now I want to turn it over to Tim. We've gotten several questions on the role of biofuels and whether we should be seeing biofuels as a good thing or a bad thing fundamentally. Someone mentioned that last week's USDA Agricultural Outlook Forum talked a lot about the future growth in soybeans for biofuel. We also had a question, would I be right in thinking that the issues this analysis identifies in FAO statistics suggest that some indirect land use change assessments in the biofuel context may be programmed in a way that is going to systematically underestimate land use impacts, notwithstanding the various other challenges in equilibrium modeling of land use? So if I could pass that tough one on to you, Tim, that'd be great.
Yeah, so let me answer the second part first, and the answer is absolutely yes, and in probably three ways. So the first is that the typical analysis of the land use requirements of biofuels, the indirect effect, assumes that if you need 1 hectare of agricultural land, we'll clear 1 more hectare at most. And in fact, what we're now seeing is that farmers aren't that precise. You clear both through kind of shifting from one region to another, or even just locally. It looks more or less like 2 hectares of land are cleared for every 1 hectare that ultimately gets farmed, at least after a few years. Maybe some are cleared, not farmed successfully, abandoned. And so the first is that actually we're clearing more land for each hectare of successful new agricultural land. The second is that the pasture analysis, a lot of the different analyses have underestimated the effect of land use change by assuming you can convert pasture into cropland and not have expansion. So the US Environmental Protection Agency analysis for an indirect land use change emissions from biofuels, Iowa State did a lot of analysis in Brazil using Brazil's pasture data and claimed in effect that there was not much of a knock-on effect, that when you increase demand for meat or price, you basically didn't see an expansion of pasture area, but they were using flawed data. And so what we see exactly in Brazil is large-scale pasture expansion that isn't captured by that data. And at least from, not, this isn't Matt's, but this other study, and also the knock-on effect that we would kind of expect to see. So that's the second thing. The third is that in general, if you're trying to do anything that's connecting your model to actual data, and the data turns out to be only estimating 1/5 of the conversion, then you're obviously got a problem with your model. So on the broader issue of biofuels, I mean, this assumption is that there is land available for all of these biofuels. Our analysis is that, just as an example, on average, to produce the amount of vegetable oil that goes into 1 mile's worth or whatever, one ton of biodiesel, or that for every ton of carbon you save from fossil fuels, you lose 3 tons of carbon from clearing of natural vegetation. Now, there's an effort by the aviation industry to try to shift to alternative fuels. And just to give you some idea, if half of aviation fuel were provided by vegetable oil by 2050, we would have to triple global production of vegetable oil just for the aviation biodiesel, on top of the already rapidly rising demand. So I think that in general, the general meaning of this is we don't have the land. And if you believe that somehow we're just going to produce all of that without clearing more land, I think it's time to think again.
Great. Thank you so much, Tim. I want to pass some questions on to Wanjira now, and Tim, you might want to weigh on this as well, but we've had several questions about how we handle competing demands. And in particular, when we look at, a 1.5 degree pathway that relies heavily on nature-based solutions, not to mention biodiversity targets, but then we also have a very clear message on the need for addressing food insecurity, to create jobs, to improve livelihoods. How do we balance these demands? Tim might want to talk about how we balance it better globally, but Wanjira, I'm curious from you in the context of Africa, how do we balance it on the continent of Africa, and what role in particular do smallholder farmers play in that solution set?
Yeah, I mean, this is this is a real dilemma for many, but I think one of the things, at least for Africa's smallholder farmers, is that we must remember that whatever we do in transforming the agricultural sector, that it includes them and involves them, because they are the majority of our food producers, and they have a lot of local knowledge. We know, for example, that there are a lot of orphaned crops, food crops that were grown resilient to certain climates that have since been abandoned, and diets are shifting to follow what is being considered a more progressive diet. So there's a lot of mindset, behavioral change work that also needs to be done around the variety of diets, the nutritious availability of very nutritious foods that are very regional, that are extremely good and would address the issue of food security without trying to expand, for example, the production of corn in the grasslands. That would be catastrophic, of course. So there's that. There's the real opportunities for crops that actually have been forgotten and that can be returned into the space. There's also the intensification. We are just not producing and optimizing the production of food, even in the land that we have. There's a lot of very old traditional production styles, but we also need to get the energy. The energy transition for Africa is crucial in driving agriculture, in driving irrigation, and opening up some of the areas that are already under agriculture into more productive agriculture. So there's a whole discussion around how we produce food and how we can do that much, much better. And then, of course, it's in the food production, in the trade side of things, where farmers, even to this day, African farmers remain the poorest in the world. And that poverty agenda has to be central. How do we ensure that there are systems, cooperatives and others, that ensure that small-scale farmers get their fair share? And so that doesn't become the only thing they have to do to sustain themselves. So I think it's going to be a mosaic of things for Africa's smallholders.
Thank you so much. Go ahead, Tim.
Yeah. So both morally and practically, food comes first. The first thing you have to do is feed people. And as a practical matter, if you're not feeding people, forest protection and climate change will have a pretty small, politically, that's just not going to matter, right? When food gets tight, governments get overthrown. And so food production will be increased. The other is that when food is short and prices go up, and we're beginning to see that now, it's not the world's affluent who eat less. It's the world's poor who eat less. So you can't kind of, if your hope is to kind of redistribute some food from the wealthy who overconsume to the poor, you can't do that just by not producing enough food, because it's the poor who experience that. So when we think about the changes, the way to redistribute that food is by holding down meat and milk consumption, bioenergy consumption among the world's wealthy, reducing food loss and waste. And in one way or another, then the market helps lower the prices and make that food available elsewhere. And I think that was, I had one other thought, but I've forgotten it now. So,
Great, thanks. So I'm going to turn to a broader question, and I invite any of you to jump in on this one. John asks for your thoughts on what the most effective theory of change is to address this problem relative to the speed at which we need to address it. Should we be looking more towards direct engagement opportunities, for example, the Amazon soy moratorium, working with local governments, versus more indirect engagement strategies where we take more global actions, try to reduce demand, et cetera? Anyone want to jump in first?
Well, first, I just want to share one slide that I forgot to share, which is this one. If you can see my slide of this is a blog that our colleagues Craig Hansen and Janet Raghunathan just did just a week ago, that sets forth kind of WRI's land strategy and basically more detail on why we think it's about produce, protect, reduce, and restore. And obviously some things are pretty easy to do if you're driving land use change in part by increasing demand for bioenergy. Just stop increasing demand for bioenergy, right? That's all being government driven. But our general philosophy is we have to dramatically increase the resources going toward the combined effort of produce and protect. It's going to have to be governments that protect against land expansion, but for them to do that, they need the support of their people and their agricultural community, which means, first of all, you need to make sure you're producing all the food you need on existing agricultural land. And the agricultural community believes it can continue to grow without clearing more land. And when Brazil was successful in curbing its deforestation, it had a produce and protect strategy. It had government efforts to enforce forest protection, but it also had lots of incentives to agricultural community to increase their yields. And then they were linked. In fact, if you were in a township that was clearing land, you didn't get these agricultural incentives and financial support. So the bottom line is this: produce, protect, reduce, and restore. And we have to hold down the demand for consumption, particularly in the wealthy world. And then we have to just dramatically increase our efforts at both yield enhancement and all the different types of ways, livestock improvements. Grazing land is treated as kind of, for those old enough to remember the comic Rodney Dangerfield, whose comic line was, "I don't get no respect." It's grazing land gets no respect. People treat it as though it's freely available. And that's in part because actually beef doesn't produce a huge amount of food for the world. But we have people like beef, and we clear huge amounts of land for grazing, and 40% of the world's grazing land was historically forested, and that's the land we're clearing. So we need to actually focus on improving grazing efficiency and then stop clearing more land. And so that we know how to do that. That's not a technical problem in Latin America anyway, that we know very well how to do that. So I think that would be our basic prescription, but I encourage everyone to look at this because Craig and Janet have done a great job of presenting kind of our philosophy of how to deal with this.
Great, thank you. So I mean, I personally really like the produce, protect, reduce, restore framework for thinking about how we tackle this issue holistically, but we also know that it's a lot more complicated and a lot more nuanced when we start to look locally at solutions. So I'm curious, Wanjira, taking that conceptual framework in mind, are there bright spots or success stories that you can point to in Africa that help us show how this can be done?
Absolutely, there are. There are bright spots in the restoration space. The fact that there's an acknowledgement that Africa has the largest restoration potential, and that we actually have to accelerate that bit to be able to restore the integrity of landscapes, even to support agriculture. I think that's important. We know much better the state of our forests. We know much better the role they play, thanks to some of the work that we do here at WRI as well. So it's really important for us to leverage all the pieces that we have. There's unfortunately still a very unhelpful debate around the agricultural sector on the continent, and so we haven't cracked that one yet, but we really do have to make some sort of movement in the right direction with respect to which is the direction that Africa's food future will take. And I hope that we at WRI Africa will be able to steward some of that thinking as we go forward. But I am definitely inspired by a lot of what is happening, and as well the discussion around circularity that is already being embedded in governments, being embedded in policy, that we cannot continue to waste and produce as if we have an endless supply. So I think that those are certainly bright spots that I see.
Thank you, Anjera. And I hope that this data can help play a role in shifting that debate and shifting that narrative into a more constructive space. We're just about out of time. I want to put one last short question to Matt. Eric Schwab asked how the changing availability of fresh water affects both land use change and conversion strategies. So I'm wondering, Matt, what you think about potential data overlays and data intersections on the water space and water availability with this new cropland data that you've produced.
Well, we see a lot of abandonment in Saudi Arabia because they were using juvenile water to irrigate the desert. And so, you know, we talk about our Oglala aquifer in the Great Plains of the US. And these are finite resources. So I think in dry lands, it's precarious situations. The Sahel goes through boom and bust cycles of good decades of rainfall and then very bad decades. So I think there's a resiliency question around water in some of the environments where it's by definition limited. So that's a big one. I also think from the water quality perspective, when you put in the really intensive land uses, we totally ignore the effects on the downstream water quality and biota and the natural, the aquatic systems that are just hammered by runoff from insecticides, pesticides, and fertilizers. So, and that, you know, we talk about the dead zone in the Gulf of Mexico that comes from corn and soybean in the upper Midwest. So water is integral to all this stuff. And it because it flows, the impacts spread far and wide. And yeah, it's a great question. I don't have an answer, but those are some of the issues I can think of.
We certainly don't have all the answers yet, but I'm hoping this data helps bring more answers to the table. I think we're out of time today, so I wanted to give a big thank you to our panelists and the data and the insights and the perspectives they brought to us today. Thank you to all of you who joined and the wonderful questions that you posed. We didn't have time to tackle them all, but like I said, we'd love to continue this conversation offline. So please be in touch and reach out. And this is really just the beginning for Land and Carbon Lab. We have additional new exciting data and research coming along the way. And we really do intend to go beyond data with this work. Our interest is not just bringing bringing innovative data to the surface, but in figuring out how we translate data into actionable information and how we put that information into the right hands at the right time to drive change. So we look forward to collaborating with all of you in that effort. And thank you again for joining us today.
Thanks, Crystal, Anjera, Tim. Thanks, Tim.
Thanks all.